Hey guys, in this video, I'm not gonna share easy and simple questions. Instead, I'll be telling real and tricky interview question answers for the experienced people. And guys, trust me, 99% questions from Java 8 will come from this video. And I'm not covering Java 8 coding questions as of now. Otherwise, video would be very longer, and that I'll do in some other videos. Okay. And guys, for now, my focus would be on the conceptual, tricky, and scenario based question. And please make sure to like, subscribe, and watch this video till the end. So, now let's get started. So, guys, first question is, why can a stream be consumed only once? What would happen if we try to reuse the same stream? So, this is very important question. A Java stream can be used only once because it works like a pipeline that processes the data step by step and then finishes. When we perform a terminal operations like for each, collect or count or maybe other, the stream process all the elements and then gets closed automatically. Are you getting my point? So guys, since the stream does not store the data like collection and only process it once, it cannot be reused. If we try to use the same stream again, Java will throw an illegal state exception saying that the stream has already been operated or closed. To process the data again, we must create a new stream. Okay. Next question is, why do we need stream if we can write code without stream API? So this is also interviewer's favorite question. So we can write code without stream API. That is true, but streams make the code shorter, cleaner, and easier to read. Before streams, we mostly use loops to filter, sort, or process the data, which required number of lines of code. Are you getting my point? Now, with the streams, we can do the same work in a shorter way, meaning we just describe that we want to do instead of how to do it. Okay, Stream also supports features like functional programming and easy parallel processing, which can improve performance in some cases. Okay, so that's why sometimes Stream is better than traditional coding. Okay. Now, guys, the next question is, can you please explain stream pipeline structure? This is also very important question. So, a stream pipeline in Java is a sequence of steps used to process data using streams. It mainly has three parts: source, intermediate operations, and terminal operations. Okay. The source is where the data comes from. It's like a set, list, or array, like list.stream. Okay. Then we apply intermediate operations such as filter, map, or sorted to transform the data. These operations only prepare the pipeline and do not run immediately. Okay. This is kind of lazy. Okay. Finally, a terminal operations like for each, collect, or count is called, which triggers the execution of the whole pipeline and produces a final result. Are you getting my point? Once the terminal operation runs, the stream is completed and cannot be reused. Okay. Now, next question is, why are intermediate operations called lazy? So, guys, intermediate operations like filter, map, and sorted, or maybe other, are called lazy because they do not run immediately when they are written. Okay, they only prepares the pipeline. The actual processing starts only when a terminal operations like for each or collect is called. Until then, Java just remembers the step but does not process the data. Okay. Next question is, if a stream pipeline contains multiple filter operations, does it iterate the collection multiple times? Please explain. So, guys, the answer is no, the collection is not iterated multiple times. In a stream pipeline, all intermediate operations are combined into a single pass. For each element, Java applies the first filter method, then the second filter method, and so on before moving to the next element. Okay, are you getting my point? So the collection is traversed only once, which makes stream very efficient. Now, moving to the next question. You are debugging a stream pipeline and want to check intermediate values without affecting the result. Which concept would you use and why? This is also interviewer's favorite question, guys. We could use a peak method. Basically, it allows us to look at the elements while they are flowing through the stream pipeline without modifying them. This is useful for debugging because we can print or log the intermediate values without changing the final result. Are you getting my point? Next question is, you are processing a list of 10 million records using streams. After applying multiple filters and a map operations, the performance becomes slow. What factors would you check to identify the problem? So this is also a very very important question. So guys, in this case, first we would check if the operations inside filter or map are heavier or slow. Second, we would check if unnecessary operations are used in the pipeline. Third, we would see if parallel streams could help improve the performance. And we would also check if the object creation inside the streams is causing problematic. Are you getting my point? So guys, these are the factors we would check it. Okay. And the next question is, a developer replaces a traditional loop with the streams, but the code becomes harder to read now. In what scenarios should streams be avoided? So, this is also a good question. So, streams should be avoided when the logic is very complex. In such cases, a simple loop may be easier to understand and maintain. Streams are best used for simple data processing like filtering, mapping, or collecting. Okay. Hey guys, before moving to the next questions, I would like to share one important thing with you. Actually, we have a complete interview preparation material structured step by step by myself, expert and MNC's interviewers. The best part is that now no one need to go anywhere else to prepare interviews. There is a 99% chance that interviewers will ask questions from this material. You can check the reviews as well. So guys, basically it contains a lot of material categorized by experience level, means each experience level has different material with all possible interview question and answers for Java, Spring Framework, Maven, Git, Spring Boot, Spring Security, Spring Data JPA, Kafka, microservices, Java coding questions, Stream API coding questions, and many more. I have provided the link to get this in the below description. And guys, if someone need this material plus two real enterprise client projects for reference, plus one-on-one lifetime doubt sessions and referrals to the big MNCs, then they should check the interview preparation kit. I'll provide the link for this as well. So now moving to our questions. Guys, next question is, can streams modify the original collection? So this is very important question. So the answer is no. Streams do not modify the original collection. Streams are mainly used to read and process data. They create a new result after operations like map or filter, while the original collections remains unchanged unless we modify it ourselves. Are you getting my point? So moving to the next question, guys. What is the difference between map and flat map conceptually? When would you prefer flat map? This is also very very important question, guys. So map is used to transform each element into another element. For example, converting a list of the names to the upper cases. Okay. Whereas flat map is used when each element contain multiple values, like a list inside a list and then list inside a list, and we want to flatten them into the single stream. Then we would prefer flat map when working with nested collections such as list of list. Okay. Next question is, why is for each is considered a terminal operations while peak is intermediate operations? So this is also a good question because both are used to show some values. So basically for each is a terminal operation because it triggers the execution of the stream pipeline and finishes the stream. Are you getting my point? And after this the stream cannot be used again. Whereas peak is an intermediate operation because it just observes the element in the pipeline and the stream continues to the next operations. Okay. So guys, next question is, why is stream not a data structure? So yes, we know stream is not a data structure, but why? Because it does not store data. This is the first thing. Instead, it is just a way to process data from a source like a list, set, or array. It simply flows the data through operations and produces a result. That's why it is not a data structure. Are you getting my point? So guys, moving to the next question, what happens if we modify the source collection while the stream is being processed? So guys, if we modify the source collection while the stream is running, it can cause problems like concurrent modification exceptions or some unexpected results. Okay. So basically stream expects the source data to remains unchanged during processing, so modifying it during execution is not recommended. Okay. Can a stream pipeline run without a terminal operations? No, a stream pipeline cannot run without a terminal operations. Intermediate operations like filter or map or maybe other only builds the pipeline, but they do not process the data. Are you getting my point? The stream actually starts processing only when a terminal operations like for each, collect or count is called. Okay. What is parallel stream and how does the Java decides how many threads to use in parallel stream? So guys, this is very tricky question and very important question as well. A parallel stream is a stream that processes data using multiple threads at the same time to improve performance. Are you getting my point? We can create it using parallel stream or stream.parallel. Java usually decides a number of threads based on the number of CPU cores available in the system, so it may vary. Okay. Next question is, guys, why can using parallel stream sometimes makes performance worse instead of better? Okay, so basically parallel stream can be slower when the task is very small because creating and managing multiple threads adds extra overhead. Okay, they can also be slower when there is too much synchronization, shared data, or complex operations, which reduces the benefit of parallel processing. Okay. Guys, next question is what kind of operations are not suitable for parallel stream? So operations that modify shared variables depend on order are not suitable for parallel streams. Are you getting my point? And also, guys, very small or lightweight tasks are not good candidates because the overhead of parallelism can reduce the performance. Okay. Next question is parallel streams internally use which thread pool? Can it affect other tasks? So this is also important question, guys. So parallel streams internally uses the fork join pool dot common pool. Okay. Since this pool is shared across the applications, heavily parallel stream tasks can occupy the threads and affect other tasks that also depends on the same pool. Are you getting my point? So guys, next question is if a stream operations depends on previous results, should we use parallel streams and why? So answer is no, we should avoid parallel stream in this case. Basically, parallel streams process elements simultaneously in different threads. If an operations depends on the results of the previous elements, parallel processing can give incorrect or unpredictable results. Okay. Next question is when should we prefer sequential streams over parallel streams? So we should prefer sequential streams when the data size is small, when the operations are simple, or when the logic depends on the order or shared data. Are you getting my point? So in these cases, sequential streams are simpler, safer, and sometimes even faster than parallel stream. Okay. What makes an interface a functional interface? Can it have multiple methods? So guys, this is also a very important question. A functional interface is an interface that has only one abstract method. It can have multiple default methods or static methods, but only one abstract method is allowed, and we could use these functional interfaces in lambda expressions as well. Are you getting my point? The next question is why does Java allow multiple default methods in a functional interface but only one abstract method? So this is also important question. So guys, basically Java allows multiple default methods because they already have an implementation. So they do not affect the main purpose of the interface. Are you getting my point? But only one abstract method is allowed because lambda expressions needs one clear method to implement. Okay. Can a functional interface extend another interface? What happens if both have abstract methods? So this is also a very important question. So the answer is yes, a functional interface can extend another interface, but if both interfaces together results in more than one abstract method, then it will no longer be a functional interface and cannot be used with lambda expressions. Are you getting my point? So, guys, next question would be what is the purpose of functional interface annotation if it is optional? So, yes, we know like functional interface is optional, but why it is important? So, guys, the functional interface annotation is used to tell the compiler that the interface should have only one abstract method. It is optional, but it helps the compiler check and give an error if sometimes accidentally adds another method that is abstract method. So, it mainly helps in code safety and clarity. Okay. Guys, next question is can a functional interface contain static methods? Yes, a functional interfaces can contain static methods as we already discussed. The only rule is that it must have exactly one abstract method. Static methods are allowed because they are already have an implementation. Next question is give some examples of functional interface. So guys, sometimes interview asks this question. So some common examples of functional interfaces in Java are runnable, callable, comparator, and interfaces from java.util functions like predicate, function, consumer, and supplier. Okay. Why does comparator qualify as a functional interface even though it has many methods? So this is a good question. Comparator is still a functional interface because it has only one abstract method, which is compare method. Are you getting my point? The other methods, basically like a reversed or then comparing, are default or static methods. So they already have implementations and do not break the functional interface rule. Okay. Next question is, what is the difference between predicate, function, consumer, and supplier conceptually? So conceptually, these interfaces represent different types of operations. Predicate takes a value and return true or false. It is used basically for conditions. Function takes a value and return another value after transformations. Consumer takes a value and performs some actions but returns nothing. Supplier does not take any input but returns a value. Okay. So, guys, next question would be, how does the compiler determine which method a lambda expression refers to? This is also very important question. So, basically, compiler checks the function interface type where the lambda is used. Since a function interface has only one abstract method, the compiler automatically understands that the lambda expressions implements that method. Are you getting my point? Next question is, why must variables are inside lambda expressions be final or effectively final? So variables used inside a lambda must be final or effectively final, so their values does not change while the lambda is using them. Are you getting my point? This helps avoid problems with unexpected values change and thread safety. Okay. What does effective finally mean? So guys, effective finally means the variables is not declared with the final keyword, but its value is assigned only once and never changed later. In such cases, java treats it like a final variable. Okay. What is the difference between lambda expression and anonymous class? A lambda expression is a short and simple way to implement a functional interface with less code, whereas an anonymous class is more detailed and can contain multiple methods and more structure. Are you getting my point? Lambdas are mainly used when we only need to implement one method quickly. Okay. So guys, next question is, can lambda expressions access instance variables and static variables? So yes, lambda expressions can access both instance variables and static variables of the class. These variables do not need to be the final, unlike local variables. Okay. Why can't we use lambda expressions without a functional interface? So lambda expressions are designed to implement the single abstract method of a functional interface. If there is no functional interface, the compiler does not know which method the lambda should implement, so it cannot work. Okay. The next question is, what is a method reference and why do we need it? A method reference is a shorter way to call an existing method by using lambda expressions. Are you getting my point? Instead of writing full lambda, we can directly refer to the method using colon symbol. It helps makes the code cleaner, shorter, and easier to read. The next question is, why was option introduced in Java 8? What problems does it solve? So this is also important question. Optionals was introduced to handle null values safely and reduce null pointer exception. Instead of returning null, a method can return an optional object which clearly shows that the value may or may not be present. Okay. Next question is, what is the difference between or else get conceptually? So both are used to provide a default value when the optional is empty. The difference is that or else method always creates a default value even if the values is present, but or else get method creates the default value only when it is needed, so it can be more efficient. Okay. Next question is, guys, what's the difference between optional.off and optional.off null label? So optional.off is used when we are sure the value is not null. If we pass null, it will throw a null pointer exception. Are you getting my point? Optional.off nullable is safer because it allows null values and returns an empty optional if the value is null. Okay. Next question is, guys, can you explain the Java 8 date time API? So the Java 8 date time API was introduced in the java.time package to provide a better and safer way to handle data and time. It replaces the old classes like date and calendar, which were not thread safe and hard to use. The new API provides classes like local data, local time, or local date time which are easy to use, immutable, and thread safe. Okay. Can you please explain the local variables were introduced in Java 10? So, guys, basically, where was introduced in Java 10 to make code shorter and cleaner. It allows the compiler to automatically detect the variables type based on the values assigned. For example, instead of writing list of strings of list is equal to this, we can write where list is equal to this. The type is still decided at compile time. It is just inferred automatically. Okay. What is record and why it was introduced in Java 14? So a record in Java is a special type of class used to store the data. It was introduced in Java 14 to reduce boilerplate code. Normally when we create a class to store the data, we need to write the constructor, getter, setter, toString, equals, and hash code. But with records, Java automatically generates them. So records are mainly used for simple data carrier classes. Are you getting my point? Next question is, can you please explain the sealed classes and when was it introduced? So basically, sealed classes were introduced in Java 17. They allow a class to control which other classes can extend or implement it. This means we can restrict inheritance and allow only specific classes to be subclasses. This helps improve security and better design control in large applications. Okay. Can you explain the virtual threads introduced in Java 21? So this is also a very important question, guys. So virtual threads were introduced in Java 21 to make handling large number of threads easier and more efficient. Traditional threads are heavier and consume more system resources, but virtual threads are lightweight threads managed by JVM. This allows JVM applications to run thousands or even millions of concurrent tasks without creating heavy system threads. Okay. So guys, this is all about Java 8's tricky scenario-based interview question answer for the experienced people. And guys, if you find this video helpful, then please make sure to subscribe, like, and watch this video till the end, and also go through that course. It will be very helpful for you interview preparation kit and complete interview preparation material. Okay, thank you. Bye bye. Take care.